Proportional and Non-Proportional Relationships, Lesson 3.6. In today's lesson, students will determine whether or not linear functions are proportional or non-proportional. Are what? Very good. So before we begin today, I want to go ahead and ask, who knows or who has heard of the word proportional? Proportional. Yes? Okay, so when you think about the word proportion, what do you think about? You think about fractions? Yes, and fractions are also known as ratios. So what we're going to do today is we're going to be looking at some XY tables, okay, which are going to depict linear functions. And linear functions form a line. They form a what? A line. And when you look at the XY values, they are either have a proportional relationship or not. So let's go ahead and begin. I want you to write the word proportional. Okay, proportional relationships are linear, okay? They form a line. If the equation is in the form of, and usually we know we've been using what for a line? Which equation for a line? We're using y equals mx plus b, right? Okay, so here we're going to talk about that same equation. We're going to say y, it's in the form of y equals kx. So you might ask, why k? Well, let me go ahead and tell you that k is the same thing as m, okay? It's the same thing as the slope. However, if, so the relationship is going to be linear, okay? Or it's going to be proportional. So if it's in the form of y equals kx, the relationship is, we're going to write again, proportional. All right? It's proportional. And if it's proportional, it will pass through the origin. Where is the origin? Where is the origin? It's at 0, 0. Okay? All right. So before we get into looking at an XY table, okay, to see whether or not this is proportional, we need to kind of go back and talk about direct variation for a minute. So this said if the equation is in the form of y equals kx, then it's going to be proportional. So we need to figure out why that is, okay? So if we just, for a minute, pretend that y equals mx, okay? How would you get the slope by itself? Or in this case, how would you get k by itself? Would you divide both sides by x? Yes, you would. So you get that y divided by x equals k. So what does that mean? Okay, k is a constant rate of change. Now we've heard about rate of change a lot. Rate of change is the same thing as the what? It's the same thing as the slope. So really what we're doing here is when we look at an XY table, we're going to put it, we're going to take the ratio of y divided by x, and that's going to be the same as the slope. And if the line starts from the origin, from 0, 0, it means that it's proportional. So we look at the ratios here. So now I know you could look at this both ways. You could clearly see if you are forming these as fractions. 0 divided by 0 is, well, 0 divided by 0 is 1. But you have 1/3, 2/6, 3/9, and 4/12. If you looked at all of these as fractions, they would simplify to 1/3. What I'm asking you to do, though, is to determine the ratio, graph it, and tell me if it's proportional, okay? So to determine whether or not this linear relationship is proportional, you have to take the ratio of y divided by x, right? which is really the same thing as the change in y over the change in x. You figure out what the slope is, make sure it's consistent throughout, and it has to start at 0, 0. Okay, so let's just make sure we know how to take the ratio. So if we take y divided by x, we have 0 divided by 0, which is 0, okay? All right, so the starting point is always going to be 0 from this point, okay? What is this telling you? That 0 is actually which intercept? It's the y-intercept, okay? So for proportional relationships, you have to remember if y equals kx, and I could actually just say that y equals mx, what is the y-intercept? Is there a y-intercept? No. In this case, they will always be 0. All right, so from this point, what is the slope? Let's go ahead and take a look at the ratio. Y divided by x is the same as 3 divided by 1, which is 3. Okay, that's the rise over run. If we take 6 divided by 2, guess what we get? We get 3. And if you want to put it over 1, that's fine, okay, when you do rise over run. What's 9 divided by 3? It's also 3. And 12 divided by 4, it's also 3. So we see there is a constant rate of change, right? So the ratio is 3. That means the slope is 3. The slope is what? It's 3. Do you get it? Okay. So if you were to graph these points, you could graph the ordered pairs if you like. You know, you could do 1 up 3. But that is the same as knowing that the slope is 3 over 1. Okay? Then we could go 2, 6. 1, 2, 3. Okay? And that would be up 3 and over 1. Okay? And so I'm going to go ahead and graph this. Okay, so this is a proportional relationship. Why? Because it goes through 0. It has a constant rate of change. The ratio is 3. And if you want to write it as 3 over 1, that's fine. K or M equals 3 over 1. And it goes through the origin. It goes through where? The origin. Very good. Okay, so now I'm going to give you an example from real life, and I'll give you an example from my life. Okay, so every Tuesday, I teach an SAT prep class, all right? And I get paid pretty well. That's why I do it. I make $45 an hour. Whoa. Yes, you should get into education. So I make $45 an hour, okay? So I created an XY chart to depict the amount of money that I make. And we're going to determine whether or not this is proportional, and whether or not we could write an equation, what that equation could be, and we're going to graph it. So I started with 1 hour. If I work for 1 hour, I make $45. That makes sense. If I work for 2 hours, I make $90. 3 hours, $135. 4 hours, $180. 5 hours, and $225. And it'll keep going. At this point, do you think that the relationship is proportional? How do you know? What would you have to do? You have to find the, what is this called? You have to find the ratio, and guess what? The ratio of y divided by x is the same thing as the slope. It's the same thing as the what? The slope. Yes, okay, it's a constant rate of change. I'm always making $45 an hour, right? It never changes. So what is the ratio then? What is the slope? Let me ask you, what's the slope? What do? You take 45, you divide it by 1, and you get 45. So the slope is 45. Rise over run would be 45 over 1. What about 90 divided by 2? What would be the ratio? It would be 45. And I'm just going to put it over 1 so you can see it as rise over run. What do you think 135 divided by 3 is? What do you think it is? Yes, it is 45 over 1. They're all the same ratio. 180 divided by 4 is 45 over 1, and 225 divided by 4 is 45 over 1. So we see that they have the same ratio. So the very important question we need to ask ourselves is, does the graph, if I were to draw this, go through the origin? Does it have a y-intercept at 0? Who thinks yes? Okay. Who thinks no? Okay, So the people that think yes, you're right. And even though I did not write 0, 0, let me ask you a question. What happens if I don't work? If I work 0 hours, how much money do I make? I make $0. Do you see what I'm saying? You understand? Yes? So in this situation where the amount of hours that you work, okay, that is going to depend on, well, how much money you make, which is the Y. It's going to depend on how many hours you work, which is the X. This is proportional, and you are going to start at 0, 0, even though it's not written. So let's go ahead and graph it. At 0, 0, that means I've worked no hours and I made no money, and that sucks. So that's why I go to work. So we have 145. If I work for 1 hour, I make $45. Looks something like this. If I work for 2 hours, I make $90. Great. If I work for 3 hours, I make $135. And you know what? I'm just going to go ahead and stop there. 135 is about there. Okay, so we see that it is proportional. Now, it's proportional because it goes through the origin, and it also has a constant rate of change. And the rate of change, what is the slope again? The slope is what? It is the ratio of y divided by x. So the slope, I know that's not perfect. Let's fix it. The slope is really if you go up 45 and over 1. Okay, that's going to be the same ratio throughout the entire line. All right? Go ahead and get that down. Now let's take a look at another relationship that's not proportional. Okay, so I'm going to go ahead and tell you right now that it's not proportional. Why do you think it's not proportional? Okay, so if you were to determine whether or not it's proportional, the first thing you need to do is find the ratios of y divided by x and see if those ratios are in fact equal. And if they're different fractions, okay, are they equivalent or are they not equivalent? All right, so let's go ahead and do that. Let's take the ratio of 9 over 1, or 9 divided by 1. What is 9 divided by 1? It's 9. Okay, what about 12 divided by 2? It's 6, exactly, or 6 over 1, that's fine. What about 15 divided by 3? What's that ratio? It's 5 over 1. What about 18 divided by 4? Oh, it's a fraction, isn't it? Yeah, 18 divided by 4, if we were to divide the top and the bottom by 2, you would get 9 over 2. Okay, or 4.5. Let me ask you, are these ratios equal? Are they equal or not? What I mean by that, does 9 equal 6 equal 5 equal 4.5? Is that true? No, sirree, Bob, it is not true. So that's why this is not proportional. So if we were to just plot these points, would this relationship be linear? Okay, I'm not sure, so I'm going to try this. So 1, 9, that would be that coordinate point right there. 2, 12, 9, 10, 11, 12. 2, 12. 3, 15. And 4, 18. Okay. There we go. Now that certainly looks linear to me. Okay? It certainly looks linear to me. But I guess the question is, why is it not proportional? Why is it not proportional? Could we figure out what the slope of this line is just by looking at it? What is the slope of the line? Okay? I'm going to draw a line through the points. Okay, it's not perfect, but it looks something like that. Okay? What's the slope? It looks like we're going from this point up 1, 2, 3, and over 1. Up 3 over 1. From 9 to get to 12, I'm going up 3, 1, 2, 3, and over 1. So what I'm saying is that the slope consistently is what? The slope is 3. Why are we not getting the ratio of 3 here? Well, that's because we're not starting at the origin, are we? We're not starting at the origin. So if we were to go over 1 and down 3, 1, 2, 3, we do get to the y-intercept, which we see is what? We see that the y-intercept is 6. So basically, if you have an equation that has a y-intercept that is not 0, in this case it's 6. So y equals, remember the slope is 3 over 1, I'm just going to say 3x plus 6. If you have an equation with a y-intercept other than 0, this is not proportional. Okay? The reason it's not proportional is because when you are multiplying by 3, y will always be 6 more than 3 times x. Okay? So this is the reason why it's not proportional. If it has a y-intercept that is not 0, it is what? Not proportional. Very good. So now we're going to take a look at some lines, some graphs of lines, and you're going to determine whether or not they're proportional. Okay, so for the first one, I drew the individual points so you could see, and I made an XY chart. All right. So it starts at 0, 0, and then it goes, this coordinate point is 1, 2, and this coordinate point is 2, 4. So the first thing I could do is take the ratio of y divided by x. So I get 0 divided by 0 is 1. I get 2 divided by 1 is 2. And 4 divided by 2 is also 2. So is this linear? Yes. Is it proportional? Why or why not? Who thinks this is proportional? Who thinks this is proportional? It is. Why? Because it starts at the origin. And if we look at the equation, does it have a y-intercept? Is there a y-intercept? No, there's not. So what's the equation for this line? It's really, really simple. What's the constant rate of change? It's 2. So the equation for the line is y equals 2x, and that is the definition, the very definition of a proportional relationship, something that does not have a y-intercept, so there's no b here, and the constant rate of change, we see the ratio is 2. Let's look at this one. Let's draw it. Come on. So you have, this is at 0, -2. We have it at 1, 1 as well. And this point here is 2, 4. Let me fix it for you. 2, 4. Okay. So if we look at the ratios, we're going to get -2 divided by 0 is 0. 1 divided by 1 is 1. And 4 divided by 2 is 2. Do you think that this is proportional? No? Why not? Why not? Well, first of all, 0 does not equal 1 and does not equal 2. These ratios, y divided by x, are not proportional. And the y-intercept is what? The y-intercept is what? It's -2. So even though it forms a line, there is not there is a constant rate of change. You know that the slope is what by looking at it? What is the slope? Because it does have a slope that is consistent. It's from this point, actually, let me go here from the y-intercept. It's up 1, 2, 3, and over 1. It's up 3 over 1, and again up 3 over 1. So even though the slope is 3 over 1, because it starts at -2, it is not proportional. So the equation for the line would be 3x, and what's the y-intercept? -2, okay? Because when you're multiplying x by 3, you're always subtracting 2, which makes it so that it is not proportional. Okay, so go ahead and get that down.